So this course is about how to use the Geographic Information System, specifically using QGIS to get the vegetable activity performance. We are going to analyze images from remote sensors or drone NDVI camera. This is the objective of the course is that we are going to delimit the area with a vector shape region. Then we are going to use the raster tool to get the statistical information, and we are going to build a chart to see the area of vegetable activity performance in a period of time to compare its performance. Okay, like this chart, like we see here, we are going to get the photosynthesis indicator or the vegetable activity from the raster file of a remote sensor, or also using a drone NDVI camera. This is what we are going to do in this course. I am going to present you a short video about what we are going to do. These areas that we see here are the areas of estuary, for example, Golden Gate, Corte de Madera, Sugar, and Corte de Madera in California. We are going to focus here in this area because we have found that this is an area with a high resilience to the droughts of California. So we can choose this vector file here. This is a vector file using the raster tools, using zonal statistics. We are going to define that we are going to use this vector file over the raster, which contains the vegetable activity of this region. And once we have this, we can get the statistical information, for example, the average for this region during July 2021. And once we have this information, we are going to be able to build a chart like we see here, where we see that the Corte de Madera region in California, it has a high resilience to the droughts that have affected the state from 2020 to from 2021, compared with another regions like, for example, Napa and Dixie. Okay, so this is the objective of this course, and this is the course topics. We are going to learn how to work with raster or GeoTIFF images of vegetable activity and wildfires. Also, we are going to learn how to use the other type of vector files for Geographic Information System, like vector and shape files, like, for example, crops database information, or also, for example, we are going to create a shape file to delimit the area that we want to study. Then we are going to define the region of interest statistics from raster and vector layers. We are going to execute query conditions with one or more raster layer. We are going to learn how to make queries against the raster files and get the conditions and get a map or an image with the conditions that comply with what we are looking for. We are going to apply a practical case of estuary of QGIS, studying the resilience to droughts, wildfires, and early warning system for California, and also in Australia, or we are going to study both sides of the Pacific Ocean. We are going to calculate the slope as a wildfire risk factor, and also we are going to learn how to work with different coordinate reference systems. For example, this is how to do, we are going to do inquiries to raster and GeoTIFF images to get the best and worst indicators. For example, this is the result of doing a query of a raster file, where we are looking for the highest vegetable activity performance of this region of California, and the result is that the region in green represents what are the regions that have the best performance in vegetable activity for California, which means that its value, it is between 0.5 and 0.94 in March of the year 2021. We are going to see the example, this short video about how to do that. For example, we have to use the raster calculator. Then we are going to use the condition. We have this condition with major than 0.5, and then we are going to use the tool of the raster to display in green what are the regions that comply with this condition that we are asking to the raster calculator. Okay, so this is something that we are going to learn in the course, and it is very important to learn these concepts, because this is how we are going to learn how to distinguish what are the resilience regions to the droughts. Okay. Next, we are going to calculate the slope, the aspect, and hillshade, because the slope and the aspect, it is a factor that affects the wildfires, the fire impact up and down the hills of slopes, and also we are going to learn what is the risk for the slope orientation west and east. Okay, and we are going to get the raster calculator to get the slope orientation or aspect, because the slope that has the west facing slope, the western facing slope has a higher risk of wildfires compared with the eastern facing slope by the position of the sun. Okay. Also, this is a theory about this is a knowledge about wildfires controlling course, where we see that the slope inclination uphill impacts on wildfires. Okay. So the fires that start at the bottom of the slope are larger because they cannot be extinguished until they reach the top of the hill. So the inclination of the slope, it is a risk factor of the wildfires, and we are going to learn how to calculate the slope using QGIS. For example, in this short video, we are going to see how to calculate, or how we are going to get the slope. In this example, we are using the Mount Whitney in California, which is the highest, or the highest mountain in the state. How to calculate the slope. Okay, we are going to see how to calculate the slope, and the result of the slope is, we have the result in blue colors, and we see that the darkest blue, it means that the slope, it has more slope than the other regions. Okay, this is how to get the hillshade, or something like a three-dimensional representation of the slope. And also we get, this is the western face of the slope, meaning that the darkest red that we see in this layer, it has a highest risk of wildfire because of the position of the slope and the incidence of the solar radiation. Okay, so this is something that we are going to learn how to calculate in this course, and it is very important to understand this type of theory. Okay, so the next slide, or the next topic that we are going to explain, is how to get the topographic lines to plan the strategy of the rain analysis. For example, we have to know what is the topography and the contour lines for the region, because we want to plan a region where is the recovering the moisture of the area with the best vegetable activity performance. Okay, so here we have a contour line for a volcano. Then we are going to learn how to get this topography, and then how to get the labels to have the information of what it is, the data of the contour lines. Okay, so once we calculate this using the raster tool for contours, then we expand the region, and as you can see, we are going to see the labels of the several altitudes of the topography of the region that we are studying. Okay, so this is another topic that we are going to learn on this course, And as you can see, we have the labels where we have the topography of the terrain and how to make this calculation to plan this strategy, okay? Next is that we are going to learn how to use different coordinate reference systems, because we have the constraint that we want to represent points on a flat map, a 2D map, but the reality is that the Earth has a spherical shape, and we must decide what type of coordinate reference systems we are going to use, because if we want to be very practical, we are going to lose detail on the separation on each square of the map, and we could face problems like, for example, the Antarctica. It looks bigger than the rest of the continents of the world. So to get the best resolution, we have to use an azimuthal coordinate systems, like we are going to learn on the course. Like, for example, this is the azimuthal map with GeoTIFF, where we have the vegetable activity layer over California, representing or using the coordinate reference system with azimuthal, okay? So this is what we are going to learn on this course, and I hope that you learn a lot. And if you have any question, you can contact me in my email that it is on this web page. Thank you very much.